Well, this is Mrs. Becky, and I'm going to try to explain to you guys how to get through section F8 IXL in pre-calculus, and that's matching polynomials to their graphs using end behavior. So I wanted to go over a couple things first. Be patient with me as I'm trying to remember how to use the software, but first thing I wanted to tell you guys and remind you is that the leading coefficient is going to be the number with the highest exponent in the equation. So in this uh, function right here, this equation, the highest exponent is x squared. The number that's with it, its coefficient, is a -4. Um, what we know is that if that's a negative number there, that's going to create a graph that opens down. Yeah, down. So it's going to have a downward shape. So it opens up down at the bottom. We know also that if you have a positive coefficient, leading coefficient, this is the highest power at x squared. There's no number there. We can assume that there's a 1 there, a positive 1. That means if it's a positive coefficient, then the graph will open up. So these are some clues that can help you to match these. Now, another clue is the last term in the equations. That's going to be the number with no x variable with it. And it's a constant because it's always like this one. Last term is a +4. It does not have a variable with it, so it's always a +4. If you stick a variable with it, this one is not just a -8, it's 8 times whatever x is, so it changes the value. But the cool thing about this last term, when the equations are in this form, standard form, is it tells us where the graph will cross the y-axis. So that's just another clue. This graph right there, we can see that it's positive, it's opening up, and it's crossing the y-axis at +7. So that looks like this graph is going to go, this equation goes with this graph. So we would write down here, well, on IXL you can drag these, but this is going to be, this graph matches, it's um, K, the K function. All right, so another thing that we want to look at is the end behavior of these graphs. So in looking at the end behavior, we're talking about where these arrows are, because these goes on, they go on and on and on for infinity. This one goes down towards infinity. So when they're talking about end behavior, that's what we're looking at, is where is it heading to? Now, the end behavior is we would look at the x-axis. So this graph, as these values go more towards negative infinity, this graph is going to continue down this way. And then as this side of the graph, as these numbers go towards positive infinity, this graph is going to continue down more and more towards another, negative infinity. So down here is negative infinity on the y-axis, and up here, these numbers go up to positive infinity. Okay, so we've already chosen this one, goes to this one. We can look at this graph right here. It's f of x, the f function. So some of the clues are it's negative, so it opens down. But if you'll notice, well, let's do this one first. Okay, for this one, we know that it's a negative leading coefficient, so it's going to open down. And it hits the y-axis at +4. And so that, looking at them, this one hits at +4, and it also opens down. So that lets us know that these match. So this graph is g of x. Ooh, this isn't easy, guys. Okay. Now, these both have the same shape, if you notice, they are parabolas, and that's the shape that we get when the exponent is, grab a different color. Let's do blue. That's the shape that you get when the highest exponent is 2. It's a quadratic. So the second power. They make that bowl shape, and they go different directions. They get fat, they get skinny, and all that. These graphs over here are cubic functions. So their highest power is a 3 to the third power cubic. And they make this little wiggly shape like that. So if we're looking, these guys were the quadratics, so these shapes don't match those the highest exponent there. But if you notice, both of these guys here, these are cubics, so you know they would match this one. Now, this last number right there, I need this red again, didn't have a number, so I wrote in a positive 0. You can add a 0 without actually changing the value of this equation. And this tells us that that equation hits at the origin. So if you look at this one, that one does hit at the origin. Now, the leading coefficient tells us that this is negative. So these cubic functions, when they're negative, you kind of read them from left to right. So as you're scanning them, so we're looking at this part of it too first, and it's heading down. So you're traveling this way, and it's going down, down, down. So that would be a negative. This is a negative graph. It's in this shape. So if you think about it, as you're starting on the left side of the graph, you're starting at the top of the graph and follow it, it's heading down. So that's a negative. And that one was, the f function. That one goes there. Of course, that leaves this last one to the h, right? Now, if you look here, see, it's this graph here is going to hit at 215. That's what this number tells us. We sure aren't going to see that. So then what we would do is we'd look at the leading coefficient here. It's a positive 1. So these cubic functions, again, starting on the left side, the farthest left side. So if we start over here and travel up, it's going up. So it's positive. That's what that one looks like. Positive. Okay, so that's what those shapes look like. And let me pause this and get a different screen, I hope. All right. So this is example number 2 on here. Let's see, what color do I have? I guess I'm in red. What I wanted to point out on these graphs is you have them now with, I hope you can see that, that's an x to the 4th. Should be on your notes if you printed them out. So if we have an exponent of 4, oh gosh, what's that called? A quart, 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 I can't remember. It's to the, quartic, quartic, like 4 quarters to the 4th power. Each time you raise this power, it's going to make a different shape. And so if you notice, it's an even number, just like when we had x to the 2nd and x to the 2nd just made that bowl shape like this. Well, the x to the 4th can make shapes that look like this one. It kind of looks like the quadratic, which is squared, it looks like a bowl. This kind of could have a bowl shape, but then it has another bowl shape. So these can have different shapes to them. They would look something like that, or kind of looks like a W, but and this is opening upward. So this one is positive. This is a positive graph. because as you look at these arrows, it's going up, up, up at each end. But also, depending on what let's see, these numbers do, these little coefficients to the x to the third, x to the second, x to the first, they all determine how many bumps and little wiggles are in it. But the tricky thing is that an x to the fourth graph can also look like a parabola because the little bumps get squished so much together that it just looks like they're non-existent. But we can notice that they open upwards, and again, they can open downwards. So this one is a negative graph. This one is, this looks like an x to the fourth, but it's opening like that one. That one is actually, where did it go? That's actually an x to the third, my bad. So yeah, that's not that's an x to the third. It confused me a little bit there, but no, it's got the x to the thirds. They're going to have one end going up and one end going down. Sorry, my bad. Like this one. This is another x to the third. It's a cubic. Um, the ends are going different ways. All right. So what else do we see here? And this one, this is an x to the third cubic. And if you start at the left side of the graph where you see it, it's going down, 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 down. So it's a negative. This is next to the fourth. I'm just looking at all the clues here. Sorry, I'm jumping all over the place. This one, as we said, is an x to the third. It's a cubic. Start to the farthest left side of the graph and follow it. It's going up, so it's positive. And this one, the farthest left side of the graph, it's opening down, so it's a negative. And that could be x to the second or x to the fourth. We're not exactly sure. But we have other clues here. We can look at these numbers. 72 is definitely off the graph. 300, negative 344 is off the graph. This one's on it, positive 3, and this is a negative 3. And again, these are the y-intercepts, where these graphs intersect the y-axis. Well, this one is hitting at positive 3. And it's positive, and this first coefficient is positive, so this graph is the g function. And again, on IXL, you can just slide those where they belong. This one is, it's negative x to the third, so it's got to be this one, negative x to the third, and that's the f function. Then, let's see, we did that one, we did that one. This is another cubic. So you know it's not that one. It's positive cubic, so this one is the h function. That's an h, not an n. This isn't easy, so don't judge me. And very last one, obviously. So the hints are, though, this is a negative, so it's going to be opening down. It is to the fourth, even though at first glance you would think that it was only to the second power, but again, they can look like that. And we know that it's hitting at negative 3, and this one is hitting the y-axis, negative 3. So bingo bammo, that's the k function. Alrighty. Let me get us a different screen here. Oops. Silly me. I guess that was it for that section. That's all the notes for that section. Again, that's for pre-calculus, section F8, and matching the graphs. I think you guys should be okay. Anyway, I think you guys can do this. And what does this look like? Looks like a parabola. It's positive. Could be x to the second, but could be x to the fourth. That's all I got to say about that. Hope you do well on that. Till next time.